2. And so if you notice, section 2.1 is on the derivative and the tangent line problem. And so I want you to just look at that graph, and I want you to tell me, what would the slope of that line be? I don't know if you necessarily need to write this part down. This is something that you should have.
2 over 1.
Okay, so remember how you find the slope is you find specific points that the line goes through. So it goes through this point, and then it also goes through 3, 3. Okay, and so what we do is we figure out the rise over the run. And so I've got my rise here, which is 2, and the run, which is 1. So I end up getting a slope of 2. I also know it's got a slope of 2 because of the equation it is. Okay, that is actually in slope-intercept form. And so I can look at this and say, oh, the slope is 2. So far, so good? All right, so let's go ahead and look at the next thing. How do I find the slope of that?
Root 1.
So what we're going to be doing is we're going to be examining how you find the slope of a curve. Okay, and that is going to be our task this chapter, because the slope of a curve is not as simple as it was with the line. And so I have something down here that we're going to read.
Just paint that around here.
In order to find the slope of this problem, we find the slope of the tangent line. Then we can plug in a given point and find the slope of that graph at any specific point. Now the interesting thing about this graph is that we never, what's the best way to say this? The slope is never consistent. Okay, so if on the line before the slope was 2 and it was always 2, the slope here is not always going to be 2. Example, oops, let's pick out blue. There we go. Here's a tangent line right here. Okay, and you're having a hard time seeing it because I have something written in there. But that's a tangent line, and that slope is actually going to be negative because the slope, it goes down, right? What's the slope of that tangent line going to be right there? 0, because it's a horizontal line, right? The one right here is 0. It's a horizontal line. What's the slope of this going to be? Positive or negative? Positive, it goes up. So you see how the slope changes as we move around the curve. It's negative, and then it goes to 0, and then it goes to positive. And that's the thing about curves. You find the slope in general, and then you plug in given points to find what the slope is at a specific point. Okay? And so how we do this is we use what is known as a derivative. Differentiation is one of the 2 important things that we're going to cover this year. We have differentiation and integration. So differentiation, which is the process of finding a derivative, we're going to spend 2 chapters on, chapters 2 and 3. Integration, we're going to get into with chapter 4 and 5. I will tell you right now that finding the derivative is easier than finding the integral of something. But the derivative is nothing more, okay, than the slope of a tangent line of a graph. And so the derivative of f at x is given by, if I were you, this is a pretty important piece of information right here. You better get this down.
That's the derivative.
That is the derivative. Now, I have seen books write it as follows, and you're more than welcome to use this as well, because this is probably what I'm going to be using in class. Now, if you didn't notice, all I did is replace the delta x with h. Okay? So that's something that might be a little bit easier for you to understand, especially when we get into some more in-depth problems. Like I said, I found that in one Calc textbook when I was looking at books a few years back. Now notice this only works provided the limit exists. Okay, for all x for which this limit exists, f prime, that is how we read that. When you see that little f with like a little, it's not a 1, it's actually like a little apostrophe thing. This is read as f prime x. Now, what that prime indicates is that prime indicates how many derivatives. Eventually, you'll be able to find more than 1. You'll find 2 and 3 and 4. Okay? But for right now, we're going to focus on 1. Now, there are different notations for derivatives, and that's what is all written down there below. Okay, you have f prime x, which is probably used the majority of the time. You also have dy dx, which is pretty important because we will get to this when we do something known as implicit differentiation in section 6. Okay, y prime, because you know that y and f of x are interchangeable, so that's another way. D dx, what that d dx means is this means the derivative with respect to x. Okay? The derivative with respect to x of f of x. And then this is another notation with the big D, derivative with respect to x of y. So those are all the different notations that can indicate that you're going to be doing the exact same thing on each of those problems. Now, a little bit about derivatives. There's what is known as the definition of the derivative, which is what we have right now. And that's what we're going to use to find derivatives today. Now, eventually, we're going to learn a shortcut way. However, you're going to have to know this way, and I call this the long way. Okay, so this is kind of like one of those essay questions that you have in social studies. You're going to have to show me the steps in order to get it correct. And it is pretty important because this will be on your final exam. So it says find the derivative by using the limit process. Now, if you pay attention, you're going to find out this isn't all in all that difficult. It's just takes up a little room and a little bit of time. So we're going to go through things step by step. Now remember, I can replace y with f of x. And I'm just going to do that because I think it'll make this next step a little bit easier for you to see. If you remember back from the definition of the derivative, there was something known as an f of h in there. Okay? Okay. Oh, I take that back, not f of h, it was f of x plus h. I said that wrong. Okay, so there was something known as an f of x plus h, so let's go ahead and rewrite that. Sorry. So now we need to think back to when we first learned about functions. How would I find what f of x plus h is? Notice I've got f of x here. I want to find f of x plus h. Right, plug in what? I plug in x plus h into x squared plus 1. So notice what I'm going to do here. So all I did is wherever I saw an x, I put an x plus h. So now, in order to make your life a lot easier, it's best to simplify as much as you can now. Okay? The more simplification you do now, the less amount of work you're going to have later on. So let's try to simplify. Do we remember what the x plus h squared will be? I hope we do. X squared.
2h plus h squared.
X squared plus 2hx plus h squared. Yep. And then don't forget your 1. So that is what f of x plus h is. So let's go ahead and go back to our definition of the derivative. The definition of the derivative said that y prime equals, or it was f prime x. I mean, it's the same thing, they're interchangeable. the limit as h approaches 0, okay, of f of x plus h minus f of x all over h. Now, as it is, I can't take the limit because the minute I plug 0 in, I get it divided by 0, which is undefined. Remember, we learned that about limits. And so, what I need to do now is plug in some things. So let's go ahead and plug in our f of x plus h that we found here. Now, we want to plug in the most simplified version. Okay, so x squared plus 2hx plus h squared plus 1. Now notice what the next part says. The next part says minus f of x. So I'm going to subtract, and what is f of x? X squared plus 1. See, that's why it's nice to have things written up here at the top. If you have those written, it's going to be a lot easier for you to just look and then plug those in. And all of that's divided by h. Now, one of the things you're going to notice is that I put a subtraction of a quantity there. I put the parentheses there because you need to understand that that minus goes to both terms. Okay? Now, this is the step we look to simplify and cancel anything that we can. Is there anything that we can get rid of?
Yes.
The x squareds, they're gone. Because you have a positive x squared, negative x squared. What else can you get rid of? The 1. What do you notice about the remaining terms? What do they have? An h. If your remaining terms don't all contain h's, you've done something wrong. That's your check. Everything left should have an h or an h squared. Okay, so equals, let's go and simplify the limit as h approaches 0. Let's see what I have left. 2hx plus h squared all divided by h. Now, if I try plugging in 0 now and evaluating my limit, once again, I'm going to get 0 over 0, the indeterminate form. So I have to try to simplify if I can. So what I'm going to do on the top here is I'm going to factor out an h. So if I factor out that h, I get what? 2x plus h all over h. Why did I do that? Because your h's then cancel. So really, it's leaving me as the limit as h approaches 0 of 2x plus h. So then now, if I go ahead and try plugging in my 0 for h, what is my limit going to be? 2x. And that is your derivative of the
Why'd you put
function.
0 for the h?
Because that's how you evaluate a limit. Remember that direct substitution? And the reason why we couldn't put it in earlier is because when we would put it in like up here, I would get 0 plus 0 over 0. And remember, that's that indeterminate form. So we had to get rid of that h in the denominator in order for us to evaluate it.
Yeah, nobody can understand what you're saying.
So we're going to look at another one, okay? We're going to try to get this limit process down. Okay, you can see that they obviously take some time, and you're obviously not going to have a lot of them to do. Okay, so
Can we pause before we start this and I go
I'm gonna go. You can go put your
pizza? I really have to do it.
Okay, so we're gonna stop, or we're gonna not stop, we're gonna go ahead and start. And so I'm gonna write it up here because I'm gonna run out of room. So f of x equals, what's f of x gonna equal? X cubed plus 2x. Okay, yeah, this one's gonna take a little bit of room. Okay, yep, this is gonna take a little bit of room. So now I'm gonna find f of x plus h. Yeah, it is. It is part of the binomial theorem, and if you can remember that, it's going to make your life a lot easier. Okay. Yeah, if you didn't hear what Christina was saying, she said this is about the binomial theorem. If you can remember the binomial theorem for the x plus h cubed, it'll save you. Okay, otherwise you might be able to just memorize it now. But remember, the coefficients are 1, 3, 3, 1. That's from Pascal's triangle. And so I start with x cubed. What will my next one be? 3x squared h. Because remember, my x's are decreasing, my h's are increasing. So your x's are decreasing, your h's are increasing, plus 3 what? H squared, good. And then plus h cubed. Okay, because what happens is your x's are decreasing, you have no more x's left, and you have your h cubed. Now, I've still got my 2 times x plus h, so that will be 2x plus 2h. Okay, like I said, doing all of this first will save us. It does save us a ton of work because we're not having to do that in the problem. So now I've got the limit. All right, actually I take that back. I'm going to go ahead and write my y prime. Sorry. Okay, so I've got now y prime equals the limit as h approaches 0. Now if you remember, I start with the f of x plus h. So I'm going to write out that whole one, x cubed plus 3x squared h plus 3x h squared plus h cubed plus 2x plus h, or plus 2h. And I'm going to subtract from that what? X cubed plus 2x. And then all of that I'm going to divide by h. What should I do next? Okay, first things I need to do is distribute my signs, and then I'll cancel. Okay, because currently if you don't distribute your signs, you can't cancel them out. So let's see, what can I cancel? X cubed, okay. What else can you cancel? 2x. Now another thing you could do, first of all now, are all h's remaining? Yes. So another thing you can do if you would like, well, I can't really combine here, but what I was going to say is, since you only have h's remaining, what you can do is you can combine the green and the yellow steps from the previous slide and actually factor an h out now. So if I take that h out now, what am I left with? 3x squared plus 3xh plus h squared plus 2h. Oh, plus 2. Plus 2. Yep. Okay, all divided by h. So then now we can cancel our h's. And then that's going to leave me with the limit as h approaches 0 of 3x squared plus 3xh plus h squared plus 2. Yeah, and so then now I'm taking the limit, and I got rid of my denominator, remember that was the problem. So now what I can do is go ahead and plug 0 in. This is that direct substitution you did with the limits again. So let's plug in 0 wherever I see an h. Okay, so first of all, I still have a 3x squared. Okay, what is 3x times 0? 0, so that's gone. What is 0 squared? 0. So that leaves me with plus 2. So your derivative of x cubed plus 2x is 3x squared plus 2. You stop when you, you stop when you have x's, all your h's are gone.
Took 3 up the top, put 3 in front of the x.
Would you just wait until next week?
Alright, I
Okay.
knew there was a pattern there.
So there is a pattern, and you're probably going to notice that the more you do. The problem is with this one is it's an essay question, and I need to see the work, and it needs to match up. Alrighty, so we're also going to look at an alternative form of a derivative. Now notice what this one is. Instead of just finding the general derivative, which is what we found the general derivative. This is actually used to find the derivative of a function at a specific point. Okay, so they're going to say find the derivative at this point. And so notice it's f prime c, the limit as x approaches c, so that's different, of f of x minus f of c all over x minus c. Once again, make sure you understand the difference between the two. Okay.
So f of c here, I was going to see.
Yes, yep. And so we're actually going to look at an example of this so that you'll have one for your homework to look at. And you'll see the difference in the problem that they ask. Okay, so let's go and look at a problem. Use the alternative form of the derivative to find the derivative at x equals c. So this is going to be the instructions on your homework. Here's the problem. So that's the one that you need to write down as the problem itself. Okay. So if we look at our formula, we need to know f of x and we need to know f of c. Okay. So I've already got f of x. Now what I need to do is find f of c. So in this case it would be f of negative 1, because that's what f of c is. So what I'm going to do now is I'm going to plug negative 1 in for x. So just like what I did on the previous slide. So what do you get f of negative 1 to be? 5. So now we're ready to actually find and use the alternative form of the derivative. So the alternative form of the derivative, f prime of negative 1 equals the limit as x approaches what? Negative 1. Yep. F of x, which will be 3 minus 2x, minus f of c, which is 5, all over what? X minus negative 1. So you can see now by having those lines written up there, it makes the problem a lot easier because you see what you need to plug in. So all we need to do now is simplify, because if I plug negative 1 in right now, I'm going to get 0 over 0. So remember, we've got to clean up this before we can actually evaluate and find the limit. Okay? So let's go ahead and clean up the top. What do I get up at the top? Negative 2x minus 2. I'm going to write it that way just because, you know, I like to always put things in descending order. And the denominator will be x plus 1. Okay, once again, if I try plugging negative 1 in right now, it's not going to work. So I need some ideas as to how you would solve this limit, because that's what we just tested over. Factor out the what? Negative 2. Yep. And when I factor out that negative 2 in the top, what do I get? X plus 1. Good. And then the denominator is now. Oh, isn't that interesting? So what happens? They cancel. So then I have the limit, and this was on your test yesterday. The limit as x approaches negative 1 of negative 2. So the limit of any constant
Is that
is
constant?
just the constant itself. That was the one, remember I asked you the limit of 9? And the answer was actually 9. Okay? So the limit there is negative 2. Okay. Now, we've got a few more things that we're going to talk about, and that's real quick here. All right?
You still want to march out of
So-
music?
I'm sorry.
We're taking stripes for troopers.
Now, real quick here, this is just, if I were you, I would not necessarily write down the graph. I would just put a graph that is not continuous. And we'll talk about what these three things are, because you've got three things. Okay? The greatest integer function is not differentiable at x equals 0 because it is not continuous. So you cannot find the derivative because it is not continuous at 0. Now that's not saying you couldn't find the derivative at other possible locations. It's just saying at 0 it's not continuous, therefore you cannot find the derivative. So you can't find the derivative if it is not continuous at that specific point. All right, that's the first thing. The next thing you cannot find the derivative of, or it is not differentiable, is a graph that has a sharp turn. Now notice, it is not differentiable at x equals 2 here. That's not saying you couldn't find the derivative at other points on that graph. It's just saying you cannot find the derivative where it has a sharp turn. So you cannot find the derivative when the graph is not continuous at a point and when it has a sharp turn at a point. Okay, so once again, what I would write down, a graph that has a sharp turn. Okay, we have one more. A graph with a vertical tangent line. So here would have a vertical tangent line at 0. So it is not differentiable there. So those are three places your graph is not differentiable. When the graph is not continuous at a point, when the graph has a sharp turn at a point, and when the graph has a vertical tangent line at a point. So those three are really important. Okay. So you cannot find the derivative when the graph is not continuous at a point, when it has a sharp turn at a point, and when it has a vertical tangent line at a point. Three things, make sure you understand. Now, this last theorem, okay, basically says if f is differentiable at x equals c, then f is continuous, and that should make sense. If you can find the derivative, the graph is continuous. Okay? So, if you can find the derivative, the graph has to be continuous, but the other way doesn't work. If the graph is continuous, that means you can find the derivative. Think back to what we just looked at. Which example would dispute that? The vertical tangent line and what else? And the sharp turn. Right here, this graph is continuous, but it is not differentiable at this spot. Okay? This one, this graph is continuous, but is not differentiable at this spot. So just because it's continuous does not mean that you can find the derivative. Okay. So these last two statements, I'm just going to read them. You don't need to write them down, but it says if a function is differentiable, then it is continuous at x equals c. So differentiability implies continuity, which is true. It is possible for a function to be continuous at x equals c and not be differentiable at x equals c. So continuity does not imply differentiability, so it's the other. Right. Exactly. Exactly. So this is what I need you to do in this section. It's kind of segmented. Okay, the first few, all the way up to 19, those are dealing with derivatives. 71 through 73 is alternate form of the derivative. 81 through 86 is looking at graphs. Okay? So, you should have everything you need.